All right. So, good morning once again. I want to welcome all of you to the Microsoft 365 Copilot and AI track. We're really, really happy to have you here. Thank you for taking our time to join us, and thank you most especially for joining our own track. We are in for a very exciting time. Trust me, you will not regret in joining this track. So that being said, like I said, I'll just quickly run us through what our housekeeping rules are before I hand over um, to Olalekan. So this session will be recorded, as you can see, and it will be made available for future viewing. Please um, do not worry if you miss anything or you are not able to attend the session even during the time it is the scheduled time. You always have access to recording. I'm supposed to, as many of those that do not have time, that's why we're recording it, and it will be uploaded to our YouTube channel. So just watch out for that. Also, it's quite very important that when you are not speaking, please mute your mic so that you don't distract the rest of the class. Pen down your questions as much as we want this session to be quite very interactive, but please pen down your questions till the Q&A session. And then you can also put your questions in the chat window. We have some of our colleagues that even before Lekon finishes class, we can attend to those questions, and those we cannot attend to, we'll let Olalekan know so that I can handle it. It is quite very important that you follow us on our social media and do so that you can get notified of future announcement that we have. Also, subscribe to the YouTube channel to keep up to date on all of our events. Most importantly, these recordings will be uploaded to the YouTube channel so you can have access to it. And then it's also very important, our associate will be sharing on the chat window um, the the attendance form. Like we said, what informs us to give you your certificate at the end of this cohort is we have like up to 80% of your attendance. So it is quite very important that when attendance is shared, you fill your attendance. It doesn't take more than a minute, to be honest. Trust me. It's just for you to mark and then be sure that the email you supply during as you're marking your attendance is the same one you use in registering for this cohort, so that it can actually register against your name. There is already an automation process at the back end that once you submit, it matches your email address to what you already submitted, and then we can mark your attendance with that. So with that being said, I'm going to be handing over to Olalekan to take over the session. Thank you all for joining once again. And then I'll say let's have a very good ride, even with our first session. Thank you. All right, Olalekan, please go ahead.
All right, so good morning, good afternoon, or good evening, wherever you're joining us from. It's just like MJ said, it's going to be an exciting one, and we are here to hold your hand. So this is a beginner class, but at the same time, we're going to move ahead of that beginner level and do some maybe intermediate or even advanced stuff in the course of this particular track. So we are talking about generative AI. We're talking about Microsoft Copilot. We're talking about artificial intelligence in general. So today's class is to introduce us into what generative AI is all about. So I'm going to start and see if this is the first time we're hearing about the word generative AI. We're going to look at a whole lot of things today. So we want you at the end of today's class to be able to, understand what we mean by generative AI and then its applications. We want to talk about how language model functions and the underlying mechanism. We want to look at the role of transformers. Many of us have been hearing GPTs and we say the T there means transformer. What does it mean? And how can we use this knowledge to, change our approach to writing our prompt, to engaging or interacting with all these large language models? What are the differences between the various language models that we have? And then how do we develop our prompts improve our prompt result skills and then get more accurate outputs. We'll also look at how to evaluate responses, and then I will run you through some of those things as regards Microsoft 365 Copilot and then the Copilot chat itself. So that is what we will be doing today. It's going to introduce us to what the track is all about. And I will be in your chats in case you want to ask questions. We've got a lot of people there that will be responding. If you want to also say something, just drop it there. They will be there to respond to your questions. So who am I? I wouldn't want to waste a lot of time on that. I think this was dealt with by MJ during the orientation class. I'm Olaliko, so you can just call me Olaliko or Ola for short. And that's me on LinkedIn, on X or Twitter, and then on Facebook. So I would love to know the students. So I would love to meet you. So you can just go into the chat and just say a few things about yourself. Maybe your background knowledge, maybe what you're looking forward to getting out of this particular track. So I would love to know your sector, your reason for joining this class, so that when I'm using examples, I want to really match that with the demography that we're dealing with. Right. I hope you can all hear me now. MJ, can you hear me? Joseph, Jeremiah, can you hear me? If you can hear me,
Very
you
loud
can
and
just
clear.
give me. All
Yeah.
right, good then. Okay, because I'm seeing something in the chat. So you can get into the chat now, say something about yourself. What do you want us to know about you? If you're an Arsenal fan, you can still drop it there. Don't deny your club. So say anything you want us to know about you, just drop it in the chat. Especially, I want to know your sector. I want to know why you're joining this class. I want to know what you're looking forward to getting out of this class. I want to know your background when it comes to generative AI or artificial intelligence in general. So I'm expecting that in your chat. Let's kickstart that. So I will be checking as I continue with the class because we've got a lot of grounds to cover today. And don't worry, I'm just running now, but I will slow down when I need to slow down for us to really understand the concept. So why this particular course? Why do you even need to understand generative AI? Why the motivation for this course? Why are we even saying anything about generative AI? In the last few years, I know many of us started hearing about Gen AI when OpenAI launched ChatGPT in November 2022. We've been hearing a whole lot of things. People will mention LLM. A lot of people will talk about chatbots. We're hearing Copilot. We're hearing ChatGPT. We're hearing RAG, agents now. We're talking about agentic AI now, image, video generation, audio generation. As a result of all this, we are now experiencing deepfakes here and there. So we want to break this down for us to understand the meaning of some of these things that we're talking about and how we can use the knowledge as individuals in our different places of work to be able to do more. So, what is artificial intelligence? We have been hearing about this. In fact, it's a topic that I taught while I was still teaching in secondary school. And then we do tell the student, oh, these are the generations of computers that can mimic human being and full stop. So we just say that over and over again. Even myself as a teacher that I was explaining that, I didn't even understand what I was talking about. I was just quoting what I was able to read in the book, and then we share that with the student, we move on. So AI imitates human behavior, by using machine learning to interact with the environment and then execute tasks without explicit direction on what to output. If we cast our minds back to the machines of old and still some of the machines that we find around us, let's take a look at television sets. Let's take a look at a fan. Let's take a look at maybe the washing machine, for example. These are machines, right? And they operate based on a set of rules. When we put on our TV set, we want it to function in a certain way. And if it doesn't do that, we will say it is broken. We need to fix it. If we switch on our fan and it's not blowing, it's not spinning, it's not doing anything, we'll say this is broken and we need to fix it, right? We expect it to do one thing and that thing every time we switch it on because those machines were guided by rules. Even till date, they are guided by rules. We expect them to do something every now and then. But artificial intelligence is different, right? It is not the kind of machine that we expect it to do the same thing every now and then. Even if we share a prompt now and we say, let's put the prompt in a particular large language model, we are likely to get different results, although something similar, but in terms of the words, in terms of the sequence, it's probably going to be different things. That is why you generate an image. I use the same prompt to generate my image, or I generate the same image like 3 times using the same prompt, and I'm still getting a kind of variation. Something is still different. It is because artificial intelligence is likened to what we call a black box. You don't even know what is happening in there that will determine what you get at every point in time. So this is a field of computer science that seeks to create that intelligent machine that can replicate, or some people are even saying that can exceed human intelligence. That is why they're talking about artificial general intelligence or artificial super intelligence. But for now, we're still dealing with the artificial narrow intelligence. So that is AI in itself. But under the umbrella of artificial intelligence, we also have certain subsets, and one of them is the machine learning. So artificial intelligence is the general umbrella, but under it, we have what we call machine learning. So what is machine learning? We say machine and we say learn, right? There are two words. Machine, we know the machines are regular machines around us, TV, radio, all those tools. And learning, we want something to learn how to do certain things so that next time it needs to do that thing, it can do it all by itself. So AI is not something that came about in 2022 when OpenAI launched ChatGPT. It has been in existence. Even machine learning started the research around 1959. But something happened in the 90s. There was a kind of a turnaround with the application of what we call the statistical approach to text analysis. So machine learning in itself, we want machines that can learn from existing data and then improve upon that data and make decisions. So we feed it with a lot of data. It will we train it using that data. So when it sees it a new data entirely, it can use the knowledge gained during the training and then apply that in making decision with the new data. That is machine learning. My own first direct physical interaction, I'll say a real life case of using machine learning, despite the fact that it is something that I've read over time, that I've thought over time, but I had to demonstrate it physically, was when I was attending a Microsoft Education exchange in Singapore in 2018. And it was that time they were introducing us to the Microsoft AI Machine Learning Studio. And about four of us were sitting down on a table, three of us, and we took our pictures, several pictures from different angles. We fed it into the machine learning studio to train the data to be able to, identify the three of us. And we then fed it a new picture, not the picture that we took and sent into it while training it, for it to now see if it can identify any of us if we feed in our picture. That is machine learning. You want to train the machine using lots of data so that next time you now say, introduce a new data, it will be able to use the knowledge and work with that. Still, as one of the subsets of artificial intelligence is also what we call deep learning. deep learning. And this is the type of intelligence that allows computer to learn from data, yes, like machine learning, but this time around, much more like the human brain. The human brain is made up of, they say, billions of neurons, lot of wires here and there, neurons of billion tiny biological cells that fire signals and connect and reinforce pathway over time. So if we're thinking, we're learning new things, our biological cells will be sending that signal. So when you learn a new skill, let's say you learn how to ride a bicycle or you're recognizing a face, your brain neurons will fire in that pattern and strengthen the connections. And then you create what we call memory or expertise. That is how the brain works. So neural network too, in the computational sense, of this particular idea, they use what we call artificial neurons that receives inputs and process it through mathematical functions. So we have a subset of AI called deep learning that uses layers of this neural network simulating what goes on in the brain, to process and make decisions. And a very good example of this is, when you talk about all these autonomous vehicles, you're talking about Tesla, BYD, and some of those vehicles, driverless cars. I mean, that you can be there and the car has a lot of cameras that is taking in a lot of data, it is analyzing and it is taking decisions. It's doing a whole lot of things. It uses what we call neural network to simulate the human brain. The way we take in information, we keep it in the memory, we learn new things, we store it there. So that is what we call the deep learning. I'm breaking all this down for us to understand how we arrive at what we will now be focusing more on, which is the generative AI. So generative AI, something that came about around 2021, and then it became like a public thing in 2022. So what is generative AI? So what do we mean by Gen AI? If you hear people say Gen AI or generative AI, we are saying the same thing. So we are talking about that um, AI, that subset of AI that can create new text, that can create new images, that can create new video, audio, can write codes while taking in natural language input from us. This time around, we want to be able to have a conversation with the AI. We don't want to write code. We're not writing codes. We want to just speak to it the same way we speak to ourselves. We use what we call the natural language. You want to write, who are you? You want to even use your audio and say, what is the definition of photosynthesis, for example? You want the AI to understand what you're saying and then put words together and give you like a feedback. That is generative AI. It's capable of coming up with new text, coming up with new image, drawing of a new image entirely, coming up with audio, sing for you, play instrument for you, come up with a video for you, write lines of codes for us. So that is generative AI. And we didn't just jump and then we have an AI that can write the text or draw the images and do all these things. It started from the neural network that I explained earlier. And in particular, one of the neural networks that we call the recurrent neural network. So that one was able to, enhance natural language processing and then be able to deal with a word in a sentence, just a word in a sentence. But after decades of research now, so researchers came up with what we now call transformers. And transformers were able to overcome the limitation of the recurrent neural network that was able to just identify a word in a sentence, not long strings of sentences and words. But transformers now overcame the limits, being able to now deal with longer sequence of text and inputs. So that is why we now have what we call generative AI. And if you look at the different models from OpenAI, you start hearing GPT. The T there is talking about transformers, and these transformers are based on attention mechanism, to be able to enable the model to give different weights to different inputs. So we will be focusing more on the generative AI today, what Gen AI is, how the model processes our prompts, so that when we understand this, we understand the foundation very well, then we will be able to deal with or use the Gen AI to our own advantage. Either you're working alone, you want to build your own, or you're working in an organization and they want you to help deploy these solutions, you will be able to not just be writing prompts, you will be able to understand the concepts and be able to do more than just prompting. We've been talking about generative AI, and in talking about generative AI, we cannot do that without mentioning what large language models are, what we call LLM. So LLM is what we call large because of two things. We call them large language model because of two things: the amount of parameters and the vast amount of data it has been trained on. So you train the model with vast amount of data, and that is why I had to put that image on the screen. So we gather data in form of text, in form of images, in form of audios, both structured signals. All these data are now being fed, trained, come up with a model so that the model can now give us new text, new code, new conversation, new image, new audio based on all the data it has been trained with. So that is how the large language model are able to give us something. When we write prompts, we get something out of it. So our large language models, we use that. We've got a lot of them, right? From different companies, from different organizations. They create their own large language model. So we're still going to focus more on all those things. But this image is like a summary of how we were able to get maybe GPT-4, for example, or GPT-4o or 4.5. It has to do with the vast the amount of parameters, which is the internal settings it adjusts to learn, and the amount of data it trains on. So when you hear DeepSeek, when you hear Llama, you hear some of these organizations, when they come up with their models, they say this model has been trained on 7 billion parameters or 36 billion parameters or 9 billion parameters. They're simply talking about the amount of data it has been used to train it. And these two, the parameters and the vast amount of data, they work together to allow it and do complex tasks like responding to our questions, summarizing text, translating languages, even writing stories, holding conversations. So that is how the large language model works. And now that we know about how we train the large language models, we have a lot of these large language models, a lot of them. depending on different companies and different organizations. So on my screen, I have more from OpenAI, and these are the models that are being used by Microsoft too. So they started from the DaVinci, text embedding, Whisper, DALL-E is for images. They came up with a 3.5 when ChatGPT was launched, and then we use 4.5 now, and then they are now releasing what they call reasoning model, the O3, the O1. All these are models. And these models, they respond differently. We are still going to look at the differences in how they respond and the best for whatever we want to do. And we also have what we call open source. Open source means it's available for people to fine tune, to tweak, and adopt. Can you see my screen? Joanne is saying you cannot see my screen.
I can see your screen.
Okay, good. Good. All right. So maybe you can just exit and then come back in. Maybe it's about the internet or something. So the large language models, we've got lots of models, but maybe for now, don't get too worried about the model in itself because things are changing. Who knows by tomorrow, you won't even need to select the model yourself. Maybe the system will just, based on your prompts, and then pick the best model for you automatically. So things are changing, but we've got different models based on the parameters, based on the data it has been used to train it, and based on certain things that these models are able to do. And like I said, we've got open source and then proprietary or closed source. Open source means it's available to the public. You talk about DeepSeek, their R model, and some other things. We have the proprietary model. Most of the OpenAI models are not in the public at the moment. So that's just the difference when you say you've got open model and proprietary or closed model. So some people want to just keep it to their chest and they don't want to make it public. But we've got a lot of open source that individuals, developers, organizations can adopt to suit their purpose. So how LLM works. So I begin to reduce my pace now for us to be able to understand the basics. How large language model works. We go to ChatGPT, for example, or you go to Copilot, or you go to Grok, or Gwyn, or Gemini, you write a prompt. You just say, who is this? Or define something. You just write in form of text. But a whole lot of steps will occur at the back end that you will not even need to see before you get the response at the end of the day. So we will look at like three key things, when we're talking about how large language model works. Machines have a hard time deciphering texts as they mostly rely on numbers. Maybe in our primary or secondary school computer classes, we say computers understand zeros and ones, right? They understand numbers, not the text. Since machine understand numbers, they find it really hard to decipher text. Then something needs to happen before these machines can understand the text that you type inside the text box on Copilot, for example, and then you expect a response. That text needs to be read by the machine. And for it to be read by the machine, we need to convert it and present it in a way that the machine will understand. And to do this, we say we're performing what we call tokenization, and which in a layman language, it means breaking text into small pieces called tokens so that the computer can work with it. And that is the example that I have on the screen. I say, this is a sample text. And then when you introduce tokenization, It's able to break the text into, you know what, pieces. Like we have it as this as one, is as one, a as one, sample as one, text as one. So this, the long sentence or your input will perform tokenization on it, break it into pieces, and then numbers assigned to those pieces. So we will take it one step at a time. So these steps, the process of breaking it into pieces is what we call tokenization. And that is one way to get our large language model to be able to perform the way they perform today. So we just drop the text. We don't know what goes on at the back end, but tokenization will occur first, meaning, oh, Jeremiah is having issues with the display. So after the tokenization must have been done, then there is another thing that will occur, and that is word embeddings. And what's the meaning of this embedding? The model will now look at how words appear together in sentences. Remember, we said we train the data, or the model has been trained using vast amounts of data. It could be data from books, from text, from videos, from audio, all over, you know, a lot of things have been used to train the model. And part of those things are text, lot of text. So embedding will look at words that are likely to show up near each other. For example, if I say king now in a sentence, it's possible that I'll probably want to mention queen, not too far from it, you know. So it looks at words that appear together in sentences, and then learn to place each words at a special point in that space. So what I'm trying to explain now is, let's look at the image on the screen. We have a dog, we have a cat, the blue one is the cat, we have the yellow one, which is a puppy, right? And then we have a skateboard. So let's say these four words, they are there in the trained data. Embeddings will look at the lot of trained data and then say, out of all these words, which one are likely going to appear close to each other? Dog, cats are likely going to appear maybe in the data that has been used to train. Maybe our model found dog and cat appearing close to each other many times. And then not too far off, puppy. But skateboard is often seen far away from dogs and cats. So embeddings means it will look at the words and try to now place them, let's say in a layman understanding. Let's say you have a toy box. You have a toy box. And in a toy box, you now want to put different things there. You now put a word, dog, you put it there. You put puppy, you put it there. You put cat, you put it there. You put skateboard, you put it there. The embeddings will now look at these words and say, dog and cat, they are likely to be together. You know, I've seen them severally in my trained data. It will put them in a place and they will sit close to each other, and it will have had the numbers to it. Look at the numbers here: 10, 2, 3, 2 in form of vector. And the second one, cat, 10, 3, 1, meaning dog and cat are often seen together in the trained data. Not too far off is Poppy, and Poppy in the vector format is sitting on 521, not too far away from dog and cat. And then skateboard is sitting far away because it is often seen very close to dog and cats in the trained data. So embeddings, the machine helps the machine, you know, to capture the relationship between words. So you write a text, a prompt, and say, um, How do I write a sentence, or give me a sentence on, or you just write maybe a word. You say, is Nigeria independent? You want to look at the words when it is giving you responses, and look at the words that are likely going to sit very close to Nigeria, close to independence, and use this set of words while responding to you. It will look for word that is embedding. The first one, break the words together in tokenization, then come up with embeddings. Look for the words that are often seen close to each other. That's the second one, embedding. So that's how the large language model works. And the third one now is the architectural developments. Okay, this is like the blueprint for each of the models. This is why we say, oh, this model is better than that model. Oh, this model is the best. Oh, OpenAI model will give you the best result. Oh, some people will say it is DeepSeek. Oh, it is Grok. It is Gemini. It is this. Most of the time, the difference will be in the architectural development. How each of these organizations are able to come up with this, changes in the design that will enable them to capture word context. Word can differ in their meaning depending on the context. It is not enough to just pick words that often appear close to each other in embedding. If large language models should just work with tokenization and embedding, they will still be giving us a lot of hallucinated words or wrong things, because context matters too. It won't just say because dog and cat do appear together. So anytime I write a prompt that has to do with dog, then cat must appear in the response. No, the architectural development will now be the one that will look at the words and say, what is the meaning depending on the context they are presented in? In other words, the sentence around a word matters to the meaning of the word. That has to do with the architectural development. So it shows how the parts are arranged, how the data moves through it, and how the model learns and make predictions. Don't forget, these models, they guess, they make predictions based on the trained data. So tokenization, it first break the words down. Embedding, look for the words as they often appear close to each other, and then based on the architectural design of the organization that developed the model, introducing context. In data science, you fine tune, you train and train and train, and then you want to rate the accuracy level of your training. So this time around, it has to do with that organization, how they are able to train their model to understand context. So if I am saying something else, it should not just work with embedding and tokenization. It should also take into consideration the context. So this is how our large language model responds to all that we say. We write our prompts. It uses our prompts, break it down, come up with embeddings, do the architectural design development will work at the back end. And all these will now result in the kind of response that we get. You know, and still on this, the transformer, which forms part of the model that we've been talking about, that advanced large language model, can still use what we even call this encoder and decoder. Encoder, in a way, is responsible for processing the input, while decoder will generate the outputs. So encoder is like a good reader that must have read and read and read and read all those things that have been used to train it. It looks for sentences in the trained data, while the encoder, it's a good writer, will now take the idea from the encoder and try to finish the sentence when part of it is missing. So take, for example, if you look at the image here, we say Vincent was a painter known for, there is nothing here. That marks in a square bracket means something is missing there. So the large language model will do the tokenization, right, and break it into Vincent was a painter known for. Because there is nothing here, it will now begin to use the architectural design to now predict what should be here. Meaning, maybe Vincent was a printer known for something, right? That part is missing. How do we now get the parts? How do we now get the missing parts? That is where your transformer that we're talking about can use the decoder and say, encoder has read a whole lot of things. And then the decoder will now say, okay, as a good writer that I am, maybe I want to complete the sentence by saying Vincent was a painter known for starry nights and sunflowers. So it predicts based on the trained data, based on the tokenizations, embeddings, the architectural design, and at the end of the day, we are now able to get a response at the end of the day, a response that we can now say, oh, this looks real, or this is true, or I can work with this. It is not every time that we will always get something that is absolutely correct, right? Because it is predicting based on all those things that we're talking about. Apart from that, the recent transformers, the large language models, the GPTs, also use what we call positional encoding. Positional encoding will look for the position of the words in a sentence before coming up with a response. For example, look at this. The cat sat on the mat. That is probably what you typed in there. Maybe you tell it to complete that and help you write a poem or something or an essay on it. The other matters. The cat sat on the mat is completely different from the mat sat on the cat. It means something very, very different. So the position of a word and the order of the words in the sequence too matter. All these will come to play when you're kind of writing system prompts, when you're trying to probably come up with your own model, or you're fine-tuning a model, or you're building a copilot and you need to write your system prompt or your own prompts. Positional encoding matters, right? So this way, it will say, right, where is the position of the cat? Where is the position of the sat? Where is the position of mat? And that will also come to play when everything. Positional encoding is key too. All these are what differentiates a large language model from another. Another one is the attention the words should get to. If we say the cat chased the mouse because it was hungry, it needs to understand what it refers to. And you need to look back at the cat or the mouse. So with what I have on my screen now, who is hungry there? So is it the cat or the mouse? Okay, so we are saying the cat chased the mouse because it was hungry. So attention to is one of those things that the transformers will take a look at. In the old recurrent neural networks, it will go to each word one by one to figure it out. But these days, the transformers will now use attention. They will look at the words at the same time and decide which words matter most. So with attention, the word it can connect strongly to the cat because the model will now learn that that's the likely meaning here. So instead of working step by step, the transformers will look in all directions and once at once, and then use the attention to focus on the important parts. So for the GTPs, the transformers, they don't read word one after the other. They look at everything at once so that they know the right order. They give each word a special positioning and coding. We talk about the vector, and then this way it will look at it together. It will understand the sentence before sharing or dropping the response with you. So these are the ways that the large language model are able to respond to our prompts. And the knowledge of this will help us when we are writing our prompts. Because we've got people that's what they do. They're like prompt engineers. They know how to write the prompt to get the best results out of these large language models. So they understand tokenization, they understand embeddings, they understand chunking, especially when they are building their own RAG for their organization, or when they are building their own co-pilot for their organization. So we will still get there. We're just laying the foundation, and I hope we're using a very good cement and block now to lay the foundation so that by the time we start mounting other things on it week after week, the foundation can still withstand everything that we're doing. And we've got differences in the large language model. We've talked about the architectural, designs and all that, but there are still other differences so that when you're building a solution and you're thinking of the right API, the right model to call. Yes, you've got OpenAI API and you want to call one of the models. You don't need to use maybe 4.0 when 3.5 or other can do the job. Maybe you don't need to use this other model when this one can do the job. For you to be able to manage your accounts, and for efficiency and to avoid redundancy. So large language models, they differ in size. They differ in meaning how many parameters they have. They differ. They differ by training data. Some models are trained on the general web text, while others are trained on domains, on special domains like medicine or law. So there are different things that can differentiate one model from the other. So let's quickly look at the image that I have here. The first one here is speed and efficiency. So that's another thing that can differentiate one model from the other: speed and efficiency. At times, some of us that we experiment a lot, you say, oh, Grok will always respond in a flash of light. When you use Grok, you write it, before you know it, it has responded. Oh, some will say when DeepSeek came out, it was very fast, but right now, it's slowing down. Oh, even in the OpenAI family, when you use a particular model there, it responds faster than a reasoning model, for example. So it has to do with speed and efficiency too. So some models are faster and they are more efficient for certain activities. Some are suitable for one thing while others are suitable for another thing. The size matters too. We call some large language model. We also have smaller models too, depending on, like I said, the amount of training data that was used to train it. So we've got big models, we've got smaller models. So if you're thinking of running it offline on your system, for example, I use Pinocchio. I run some of these models on my PC. Maybe I don't even want to feed my data on some of those models online. You can run some of them offline. But if you want to run it offline, of course, I'm not going to run a huge large language models with big parameter on my system when my system is not built for that. So you can easily run some of these smaller models, 7 billion parameter model. So it's Sizes matters too. Sizes matters, right? And also open source versus closed or proprietary. We've got models that are open source, free to use by people. You see a whole lot of that on Hugging Face. You see them on Pinocchio. You see some of them on GitHub. People can go there, use the model, adapt the model, train the model to suit their own purpose. And you've got closed models. They are not giving us access to what they have. So that can differentiate a model from another model. You also have models we call general purpose, and then you also have models that can do specific tasks, that has been fine-tuned to do specific tasks. General purpose can do many things. They are good at many things. Maybe you want to talk about maybe GPT-4, 4.0 and all that that can do a whole lot of things. But there are other models that have been built for specific tasks. You've got models that can do more with text, that can write better, that can perform better with summarization, translation, answering questions. You've got models that are good when it comes to STEM, when it comes to mathematics, when it comes to writing of codes. So there are models built for different purposes, and you can identify all these models so that when you're doing something, you pick the right model that can give you the best results. So even if you're using Azure, you're using AI Foundry, you're using all these platforms to build lot of solutions, you will be able to select the model that you feel will give you the best results. So you need to be mindful that all these models, they can do better at different things. Okay, so that's um, some are text only, while some are multimodal. Text only means they will only accept text from you and they can only give you text. Whereas you've got some that can accept images from you, accept document from you, and can also give you text, images, documents, PDFs, codes in return. That's something too. The architecture matters too. So the architecture matters too. Some are still using the old recurrent neural network, while most models now are using transformers. So that can differentiate it too. Then the language coverage matters too. Some are very good at certain languages at the moment. When OpenAI launched ChatGPT, it wasn't that good with Yoruba or different words, but right now they can do better. It's kind of fairly okay now using writing in Yoruba or even adding Ami and doing some of those things. So these are different things we can use to differentiate one model from the other. We've got lots of models, but the good thing is you just need to know how to use some of these tools, not necessarily be able to break them down and dissect them. And like I said earlier, we have large language models and we have small language models. Large language, small language models. Obviously, from the name, large language, this large language, a lot of data, billions of parameters, vast training data. On the other hand, the small language models, they are specific language focus. So not just everything, fewer parameters, focused data sets. So they have been trained specifically to undo, fewer things. So we've got large language and small language model. So depending on what we want to do. So now that we've talked about large language models, we've talked about how they respond, how they operate. We've talked about the tokenization. We've talked about the embeddings. We've talked about the positioning. We've talked about the attention. Right now, what and how do we interact with a large language model? So how do we now interact with the large language models. Okay, but before I move on, I just need your response in the chat. So far, so good. I'm moving too fast, or it seems too complicated, or you want a 1 minute break to grab a cup of coffee. I want your feedback in the chat. So, one word for what we've done so far in the chat, one word for what we've done so far. So, all along, it's just the general introduction. But right now, we're now going to be more specific. Okay. Oh, Salawa to say it's amazing so far. Okay, that's good to know. So yeah, tongue twister break. Okay, Jeremiah, you want to give us tongue twister? Okay, Salawa saying I can still slow down. Okay, that's thank you for that. I can slow down. What about others? Okay, Praise is saying I can fire on. Here. So let's drop our messages. Okay, a bit complicated. I know. It could be a bit complicated, but the complication here now is just for you to understand what goes on at the back end. So it's not as if we're going to be using all that, to do many things, but just for us to have a good understanding of how these two, how they work, you know, how they work. We just want to understand that we don't just write prompts and then this Gen AI, we just figure it out all by itself. That's why we had to talk about the tokenization, the embeddings before the work. But this is what you now need to pay a lot of attention to, right? Prompt engineering. We said we'll give large language models, we'll write text to large language models. And at the back end, the perform tokenization, embeddings, and all that before giving us a response. So how do we now interact with Gen AI? What is that input that was sent to the Gen AI? What is it called? So this is what we call prompt engineering. Okay, and this is what you need to pay attention to because it will define how you interact with your out of M365 Copilot. It will determine how you are able to even instruct your co-pilots in the Copilot Studio how to behave. And this is prompt engineering. So to interact with the AI model, to interact with the large language models that we talk about, we need to learn to give it clear and concise instructions. So this set of instructions are what we call prompts. Okay, so you've got a poll on the screen here. You've got a poll here. So which subset of AI involves training algorithm to learn from data and make predictions and decisions? So you can just respond to the poll. You can respond to the poll as we continue. So you can respond to the poll, and
So it's just sort of a icebreaker, when they ask for it.
yeah,
Yeah. All right
yeah.
then.
All right. No, it's good. It's good. It's good. Right. So I was saying prompt engineering, right? We're saying we'll write text, we'll drop it in the large language models, and we expect a feedback. So what is it called? It is called prompts. And being able to now write your prompts to get the best out of this model, it is a skill that you need to learn. And that skill, you drop it there, you iterate, you change it again, you send back to it and say, this is not what I want from you. I want you to write it this way, or you introduce new context, or you add more examples. You give it all these things. In the process of doing that is what we call prompt engineering. So how you interact with the large language models. Okay, so I hear a lot of time people say, oh, the large language models are not responding well. They're not providing users with the right responses. What happened is maybe you're still not writing your prompts in a certain way to get the best out of the large language model. So prompt engineering is what we need to pay more attention to. The quality of your response, the quality of the responses from Gen AI not only depends on the large language model, but also on your types of prompts, also on the prompts the users provide. Even if we're using the best large language model, even if the large language model has the best set of architectural design, it's the best, it is good, it is awesome, if you don't even give it the right set of prompts, it will not even be able to do all those tokenizations, embedding, all those things, and give you the best results. So how do we now get the best out of these large language models? What do we mean by writing good prompts? This is what happens when you write your prompts. For example, you write your words and you send it in. The large language model will not see it as a sentence, will not see it as a statement. It will see it as a sequence of tokens. That is why I mentioned tokens earlier. It will break your prompts into tokens and then work with it that way. So when we now write our prompts, all these will happen at the back end before the large language model will now respond and give us something that we can either applaud as saying, oh, this is good, or we say, oh, this is not what I was expecting. So it is prompt engineering. Right. And there are what we call elements of a good prompt. So if you really want to get the best out of these large language models, you must be able to write your prompts. There are lots of resources out there now. OpenAI shared a document on prompt engineering. Google shared a document on prompt engineering. Microsoft has tons of documents and resources on prompt engineering so that people can learn how to get the best out of all these large language models. Because a lot of work has gone into building these models, and we need to learn how to write our prompts and get the best out of it. So I will summarize the elements into these 5 key areas. The list is not complete, right? I'm not saying this is everything, but if you even take note of these 5, you begin to see changes in the responses you get out of large language models. Number one, what we call role play or what we call persona. So if you're using your co-pilot, you're using ChatGPT, you're using Gemini, you want to be able to tell it to take a role. You want to tell it to act as something. I'm a data analyst, for example. Maybe I use Excel, I use Power BI a lot, I use Python, SQL, and what have you. And I want to prepare my co-pilot to assist me. I can tell it and say, act as a data analyst with vast experience in Excel, in Python, in Power BI, in SQL. I have prepared it. I've said, make sure you now assume the role of a data analyst before I even ask it to do anything. That alone can change the quality of my response by saying, act as a data analyst of 20 years of experience, and you're very familiar or you're very good in Excel, Power BI, and so on. It will improve my response. Maybe you're a business developer, you want to get something out, you're analyzing your business, you want to find your competitive advantage over your competitors. You can even tell Copilot and say, you are a business developer with 20 years of experience. You've run businesses that have, reached a unicorn and what have you. Help me out in this new scenario. You have done what we call role play, and role play can help improve the responses from a Gen AI. That is number one. Number two is the objective. What do you really want the Gen AI to do? What do you want the large language model to do? That is the objective, what you want it to do. I'll go back to my example. As a data analyst, act as a data analyst with 20 years of experience. Give me give me the DAX for creating a calendar table. That is what I want from it. Because I already said act as a data analyst that is vast in Power BI, it will be able to respond better to my question, which is the objective, what we want it to do. The third one is the audience. Who will use the tool? Who will use the response? Because if I want ChatGPT or Copilot to give me the definition of machine learning, for example, it will just give me the definition of machine learning. It could be something that is suitable for a PhD level student. It could be something that is suitable for an undergrad. But maybe I am just teaching primary school student machine learning. If I give them the definition that I gave you this morning, they won't even understand what I'm saying. But if I now tell Copilot and say, give me the definition of machine learning that is suitable for a primary school student, then Copilot or ChatGPT will adjust and say, I don't need to just give and use big grammar. I need to just explain it in a way that a grade 5 will understand. So audience matters too. Who will consume your response, or who will be using your co-pilots that you want to develop? Or what do you do in your organization if you are the one responsible for the system prompts? What do you do? Who are the people that are going to be using it? Audience matters. So when you want to write a post that you want to put on LinkedIn or Facebook and you want to leverage GenAI, you can add it there. My audience are people that are new to technology. Oh, my audience are majorly Nigerians. If you had that, Copilot can introduce, maybe pidgin, or introduce locations in Nigeria, or introduce common words that we use in Nigeria in the response, because you have added the audience that will be using whatever response you want to give it. If you're thinking of defending your project and you want GenAI to help you with some words while you're preparing for your presentation, if you have the audience there and say, oh, give me a paragraph to introduce my project topic to my project supervisors who are professors in this field, they've written a lot of books here and there, published journals and this and that. It will take that into consideration while responding to you. So it will not just give you something that is generic. It will not just give you something. It will look at your audience. That is why audience too is important when you're writing your prompts. You always want to specify who your target audience are, so that it will take that into consideration while responding to you. So we've talked about how many now? 3: role play, or what we call persona, the objectives, and also the audience. The next one is the context. Is there anything that you want Copilot to know before responding? The context matters too. Or maybe I want to say, I want to write a short note. For example, look at one on the screen. I said, act as an helpful tutor. That has dealt with what? Persona. Who breaks down complex subjects into easy explanations. I want you to explain the process of photosynthesis. That is the objectives to a 14-year-old student. That is the audience. And wait for the next thing, to assist with biology exam preparation. That is the context. So if what you want is, oh, I want to make a presentation at Microsoft Build, oh, I want to make a presentation in the university for the law students on the use of artificial intelligence, give me like a paragraph to introduce the presentation or to start my talk. The context matters too. So you've given it a context. You want something like on hook to help you start your presentation, or you've been invited for a TED talk. You want a hook, or you want a story, or you want something. You can give it a context. The reason why I want this response from you is because I am writing a book, or I want to use it in my presentation. Large language models will look at this and say, oh, I think I understand why you're doing this. You can even add more information while you are requesting for that thing from large language models. Oh, I am in my final year in the university. I need to defend my project and I've been given 15 minutes. This is my project's topic. I've done this, I've done this, I've done that. So what are those things that I should prepare myself for, as questions, likely questions from my supervisors? If you give it enough context, it will be able to respond well to you. I had an interview around, I think, April 2nd or so. And what I did was to research the interviewers, got a lot of information about them, the kind of journals they've written, what their focus in terms of papers, in terms of, their skills, their departments and all that. And then fed in even my own paper, and then said, give me the likely questions that I can be expecting from them. Fed it a whole lot of things, and then it came up with questions and how I can respond. So when I was facing them at the interview, I was just laughing because they were asking most of the questions that I had prepared for. And I had the response. I know what they love to hear. I know what they're working on. I know what they've worked on in terms of their papers. So I was injecting that in my responses. So you can give it enough context why you're sending that feedback or that input into the large language model. The last one is the boundaries. You can tell it the directions it should go. Okay, I just want bullets from you. Give me this in bullet forms. No fluffy. Don't add stories. Just give me in bullet form. You know, that's fine. Or I want it in tabular form. Put it in a table. Oh, I want you to simplify it, stage by stage. You can give it boundaries. I want it in 100 words. At times, I'll just say, explain deep learning in 1 minute. Maybe I want to use that for my contents. Maybe I want to use that to explain to somebody, or I want a storyline in about, that can finish in 30 seconds. You can give it boundaries. So in summary, give clear instructions, provide context, and then you continue to iterate and experiment. In the course of this track, we will build a co-pilot, an AI agent, and we will iterate a lot. We will continue to tweak and tweak and tweak and test it till it will be able to give us, something that we feel so much confidence in, something that we're confident in, something that we now believe this can be published, this can be pushed out there. So elements of a good prompt include your persona, objective, audience, context, and boundaries. And this is not all. Like I said, this is just like the basics. This is just like the basics that anyone can adopt, that you can use. But beyond this, you still have a kind of advanced prompt engineering. And I know in another week we will be able to dissect this better, because I'll still want to, show us one or two things, kind of hands on before we leave. We have what we call zero shot prompts. I may not be able to go into details today. So these are still some kind of prompt engineering examples: few shot prompting, chain of thoughts, tree of thoughts. These are kind of advanced level prompting that we will be using, especially when we are building our own chatbots, when we are building our own co-pilots, and we want to feed it with all the system prompts at once, so that when anybody is using it, it's able to respond to us in kind. Maybe you're thinking, how will this be useful to me, even as a person now? Maybe I should just chip that in now. At the end of this track, you can be building chatbots for different organizations, right? This is different from what we normally get on the websites that we only respond to FAQs. We'll just be telling you the same thing, will not respond and give you desired results. This one will be powered by Gen AI and will be able to respond to the needs of the users. So you can help organizations, you can help banks. Banks are now using this to reduce the tension on their customer care department. So they have like a platform where customers can just go ask their questions, interact with the Gen AI back and forth. So most of the time, their problems will have been solved and they don't need to now, visit a person and disturb them. So you need to learn how you can do all this going forward. And that is one of the things you will also learn: how to now write prompts to interact with all your documents, get the best out of it in Microsoft Word, in Excel, in PowerPoint, in Power BI, on Teams, in Azure, how to use the Copilot in all these applications. And prompt engineering is critical, because the quality of the response will be determined by your own prompts too. So most of the time, the results may not necessarily be what we want. So how do we improve the results from these large language models? So at times we'll just write a prompt and it will give us something and we'll feel like, oh, this is not even giving me what I want. How do we improve the response? Let me even go back and take this off the screen. Maybe one person, I can allow it, you want to use the mic and just share with us what are those steps that you've taken before to improve the quality of your response, of the response from your large language model. So let's say, oh, you wrote something in ChatGPT or Copilot and you didn't get the best out of it. Well, what are those strategies that you've adopted? You can drop it in the chat, and if you want to unmute as well, that is fine. So you wrote a prompt and it's just not giving you what you want. So what are those strategies that you've adopted? So anybody, you can drop it in the chat, or you want to respond by using the microphone. Give it feedback as in, oh, I don't like your response. Okay, that's one. But oftentimes, it may still give you something that you won't even like to, because you only told it, you dislike the response. You can actually do more by saying, you know what, I am expecting it in this direction. This is something that I would love to get from you. Instead of just saying you dislike the response. But that's a feedback from you. Thank you for sharing. Who else? Hold it. I say, let's start on a new sheet. Okay. Saying I gave it more direction. That's cool. You can give it more direction, give it more context, and say, this is what I'm looking for. This is why I'm asking you to do this. Praise is saying you rephrase and add this and that. That's still another way of telling it what you want it to do. I'll respond to your question around model context protocol. That's it's now being mentioned here and there now, and then the difference between building your own chatbot with Copilot and then using MCP. We'll respond to that maybe after the class. You give it more details on what you want. These are ways that we can improve the results. And I have this on the screen: prompt engineering with context. You give it more info. You can even give it sample response that you are expecting from it. So from all that you gave in the chat, you give it more direction, you rephrase it, you give it more details on what you want. You are iterating. You want to use all this to improve the result. So by doing all this, you can get better results. Tell it why you're doing what you're doing. Add the context. Give it the audience. Go over it and over it again. That one is easy and cheap. We can do that to Copilot. We can do that to ChatGPT. But on another level, we can do what we call retrieval augmented generation. That is what we call RAG. This time around, you are using the model, the large language model, in your organization. So you want to connect the organization's database to it and build your own RAG this time around. So this involves retrieving the relevant information from the company's data, and then you use it to generate responses. So this time around, you are not telling Copilot or ChatGPT to just be using the trained data to give you responses. You want to build your own RAG this time around, your own Copilot built on the knowledge base of your organization. Build on the knowledge base of your organization. So this will help in generating more accurate and relevant answers. Instead of only using what the model already knows, RAG will first search for the most useful facts from your trusted data, from your own data. So that is another way of improving results. So maybe at the end of this training, you find yourself in an organization that they are using their own, they want to just close the large language model they are using. They want it to just focus more on their own data so that it will not just be giving you something that is everywhere. And this is what we will do with Copilot Studio, for us to see how to create a Copilot, connect it to the knowledge base of your organization, be it the SharePoint, be it your files, a website, so that it is not just fetching information from the vast amount of data that has been used to train it, but just your company's data, but powered by the Gen AI. That's still another way to improve results in a closed organization, and that will be demonstrated in another week. You can also fine tune the model. So maybe you've been hearing people saying, oh, they are fine tuning the model. So this involves you taking a pre-trained model, maybe all those open source. You now want to further train it on a smaller task-specific data set, maybe your own data set, to make it more suitable for a particular application, that is expensive. That is not something that we can easily do with all these tools out there. So it's useful for adapting models to domain specific requirement. Let's say we now have AI platforms that will tell you we are the first AI law firm. So maybe you've come across such AI platform. It's because they've now fine-tuned the model to now be able to perform better as a lawyer. Or you have platforms like Gmind, like different educational platforms out there. They fine tune it for educational purposes. Or we have one that has been fine tuned to be used by doctors. So one can now fine tune it and say, this is what we are using it for in our own logistic company, in our own hospital, in our own law firm, in our own school institution. So we can fine tune the model and then train it more on our own data. So that is how to improve result from the easy and cheap, which is the one that should concern you most now, which is just your prompt engineering, iterating, retweaking, making sure you get the best out of it. So how do you now measure the response quality? You've given it a prompt, it has responded. How do you measure it? You assess the accuracy and the relevance of your content, because we are going to be building, like I said, Copilot, we'll be using it. So we want to test when I feed it an input, what's the quality of the response? Before we even ship it, before we publish it out there for people to use, you want to check, is this relevant? Has it been given us relevant and accurate content? Because performance and quality evaluators, you are, in a way, you want to check if the AI's answers are correct, are clear, and useful. If not, you want to look at your knowledge base again and see if you probably need to do your chunking again and all over again. Risk and safety too. So you want to check if the answers might be harmful or unsafe. So before you deploy, you want to check. I get feedback from people that will say, oh, I saw your video, I want to try this, but Google View or ChatGPT or Copilot is refusing, to respond to my prompts. It's saying something is unsafe there. It's saying, oh, I'm unable to respond to this. It's because we can also evaluate the quality of the response, if it is harmful or unsafe, before we deploy something that can harm people. We had the story of a boy, eh, not in Nigeria anyways, somewhere in the world, that killed himself because an AI told the boy that, have you tried committing suicide before? And then, what are you waiting for? Go and try it out. So you need to be sure that the response is safe. And then you want to check that, is it performing as expected in your own industry? Is it focusing on what matters most for your industry? So we will be using the 365 Copilot. We will be using the Copilot Studio to create different things. We should be able to check the quality of responses before we finally say, oh, we want to publish or we want to run with whatever we have out there. And while building whatever we are building, it has to follow the principles of responsible AI. So whatever we are doing, whatever that we are doing, no matter how brilliant you are, you know how to build your own AI chatbots. You can, you understand embedding, tokenization, you understand all those things. In fact, let's say you can even build your own model from the beginning. We must obey the principle of responsible AI. And Microsoft is known for promoting this responsible AI for social good and all that. And number one on my list here is fairness. So whatever solution you are building, you can check some people out. You can tactically, be biased to some people with the custom prompt that you must have set at the beginning. While you're building your Copilot, you're writing the system prompt, you can tactically introduce something there and be biased. But we don't want that. We want you to always obey the principle of fairness. Okay, take for example, for us to see it in proper context. If you're building a loan application and your loan app at the back end is discriminating by gender. So maybe you're writing your prompt and saying, the loan app should kind of favor the male over the female. You've written your own system prompt somewhere at the back end. And the people that are going to be using the model, they won't even know. They will just be feeding their information there, and tactically, you'll find out that it will evaluate them and say you are not qualified. While the other person will say you're qualified because of biases. So models can have biases depending on the people that must have developed them. So you also need to understand to build systems that will be fair, that should treat all people fairly. Maybe it's not even gender. Maybe it's about geographical location now. Maybe I'm building a model and tactically I am not favoring the people from a particular area of the country. That alone have introduced biases, and that is not fair. There was an issue, I think earlier this year, and some people protested that a particular loan app usually automatically rejects people from a particular geopolitical zone in Nigeria. So two people will stand together, they have the same amount in their wallet, and they are both applying. Just because one person chose a different state as the origin, the solution will automatically reject that person, while we'll go ahead and approve the approval from another person. That is bias. So we don't want that. Whatever we are building should be fair to people. The second one is reliability and safety. Error may cause harm. So we want to be sure that our systems are able to perform reliably and safely. For example, the autonomous vehicle that I mentioned, before um, Tesla could ship those vehicles out, they must have done a lot of testing, a lot of diagnosis, to be sure that, this thing has been tested and can work. So whatever we are deploying, we must have tested it over and over again. I remember when my brother came to pick me at the airport, and we're traveling like an hour, 30 minutes to his place. And he came with Tesla, and he asked it to just do the automatic driving, the autopilots. So the first 5-10 minutes, I wasn't comfortable. I was just saying it to myself, boy, better hold this steering, because I'm like, this thing is just turning all by itself, was navigating, was stopping, was obeying traffic, but I was not comfortable in the first few minutes. I'm just like, I beg you, just hold this thing very well. But after a while, I sat back and I'm like, this thing sabi this thing, oh, and it was just turning, was moving, was obeying traffic, was stopping, and I'm like, this is good. So they've done a lot of testing, a lot of simulations to be able to finally say it has, next to zero error. So whatever solution we are shipping out, we must have tested it and be sure that it is reliable. If we're pushing out a chatbot for a school, and we want the chatbot to help the student calculate CGPA. For example, I'm working on like a co-pilot for a tertiary institution. One of those things is we want it to be able to help students. Students can put in their data and then it will help them with their CGPA. If it is flawed at the back end in terms of the calculation, the student that ordinarily maybe should have been told that you need to do more, you are presently in third class. Maybe the whole thing did the wrong calculation and told the poor boy that you are in 2-1, you are doing fine. And the boy will just say, oh, I've been 2-1, I'm doing fine. So it has to be reliable and then safety. Privacy and security. We have to build solutions that must be able to respect people's privacy. Models that are based, that can rely on not just the large volume of data, but will be able to, you know what, protect people's data. Please, if your organization is against you putting their data sets on all those public large language models, we shouldn't do that. Or maybe you are a data analyst, you've gotten a job and you want AI to help you figure it out. And you just copy the entire CSV file and you upload it on the large language models. If they should know, you'll be in trouble, right? So data privacy and security. A medical diagnostic bot is trained on sensitive patients' data, which should be stored securely and not stored insecurely. So if your company has given you a lot of data to be used as the knowledge base for building your chatbots in the company, you should not now, because you've got access to the sensitive information, you now start sharing those information out there with people. Privacy and security. Or maybe because your solution accepts PII, private identifiers from people, and then because you've got access to it, you now want to be using it against people. Don't be like that. Is the access bank guy that installed CCTV camera and was capturing people because maybe that's his department and all that. So we want to obey privacy and security. Inclusiveness too is one of those things. Inclusiveness. Systems that should empower everyone and engage people. It should benefit all parts of the society, regardless of their physical ability, gender, ethnicity, and other factors. That's another principle. Inclusiveness. Maybe you're building an application, for example, a predictive app that provides no audio output for visually impaired people. If you check Copilot, you check ChatGPT, people can talk. If you cannot type, maybe you've got, if the person has issues with the limbs, you can still talk and you get feedback. If you cannot see, Copilot or ChatGPT can still talk back in form of audio, just for inclusivity. That's another one. And transparency. Transparency. System should be understandable. Users should be made fully aware of the purpose of the system. So that is why if you're building like a Copilot, for example, the first thing it will probably show you is, this is me. This is what I'm able to do. You can put all those things there for people to now see that, okay, this is what this Copilot is all about. And this is how I can interact with it. Transparency. In China, for example, I read their own AI policy. For you to come up with your own model, you must be able to disclose the trained data, algorithm, and everything with their own government. It's kind of scary. So they want to ensure that at least people are not just building things. Maybe that's cool. Maybe that will prevent different people from just coming up with models that can just do and undo. Accountability. Who is liable for the AI-driven decisions? Yes, AI can do many things, but at the same time, the final decision lies with us. right? And this has to do with the framework of governance and your organizational principles to ensure that the solutions meet the ethical and legal standard. Okay, so accountability is key too. So when you understand all these principles, every other thing that we are going to be doing from next week, my session today, it's talk and talk. I hope maybe there's going to be another week that's going to be, fully hands-on. I'm sure from next week it's hands-on, hands-on, hands-on. But we need to understand all these principles before we start building our own models. We start building things and we start saying, oh, this is what we're doing. So today, I want to just do a quick rundown, and then I still want us to have a feel of the Microsoft 365, and then some of those things that we're talking about. We started off by talking about what artificial intelligence is all about, machines mimicking human being, then machine learning from data, deep learning using neural networks to process data similar to that of the brain, then Gen AI for us to be able to um, come up with new text, new code, new images, new audio from ordinary text. And we said that the large language models were trained on vast amounts of data, including text, images, speech, structured data, 3D signals, and this model will now be able to give us new text, new conversation, new code, new images, new audio based on all the things that have been used to train it. And then I also shared with you some of the large language models around GPT 3.5, 4, 4.0, 4.5, and the differences between some of these models, right? And then how LLM works. We said it adopts tokenization, breaking the words, the sentence to words, and then assigning numbers to it for it to be properly read in, and then embeddings, capturing the relationship between words, how words are often seen together in the trained data, and then the architectural development. So we then focus more about prompt engineering, meaning how we write our prompts, incorporating the elements, persona, role, objectives, audience, context, boundaries, ensuring that it's able to give us what we want. And we said we can improve the results by iterating through our knowledge of prompt engineering, going back, giving it more context, or if it is something for our organization, we are talking about RAG, or we fine tune and we do all that. Okay, and the metrics, we want to check the quality, check if it is safe, and check if it meets the needs of that particular organization. And finally, it has to do with the responsible use of these tools. Okay, so the link on Microsoft Learn has been shared for us to also, go back to those things. It is just to give us the fundamental on this knowledge of what Gen AI is all about, right? But at the same time, before we go now, I wouldn't just end the class without us at least seeing something. Let me share another screen now. Okay, all right. So right from here now, we've talked about co-pilots and all that. And maybe we're like, what's the difference? There's a co-pilot chat. There is a Microsoft 365 co-pilot. There is also what we call the co-pilot studio. You can have access to the co-pilots using different platforms. If you go to copilots .microsoft.com. If you go to copilot.microsoft.com, you will arrive somewhere like this, where you will be able to write the prompts that we talked about, you know, If I just put this there, write your prompts, it gives you responses. You can have access to it on copilot.microsoft.com. If you are using Microsoft Edge as the browser, you also have Copilots here, meaning you can just come here and activate Copilot. Maybe you are even on a different page. You are on a different page and you quickly need to ask Copilot to help you and you don't want to go outside of your browser. You can open up Copilot here and you will still be able to know what, respond to it here. That's another way. If you are using Windows, you also have Copilot as part of the Windows application on your PC. So you can still have access to Copilot from here. So this is the Copilot chat where you can drop questions, expect responses. You drop questions, you expect responses. You also have the Microsoft 365 Copilot. So this one will be able to do more than just the Copilot chats, meaning that if as an organization you've deployed Microsoft 365, the Copilot there, I'm in my 365 here. This is the 365 where you have access to all the Microsoft applications that are available, and you have co-pilots here. So the co-pilots here can interact with all your documents, all your files. You can reference a file here and say, you know what, create a presentation, using maybe you want to reference a file, you want to call an agent, you want to reference a file in your 365 domain, your tenants, your SharePoint. 365 Copilot has been embedded there, even in your Word, in your PowerPoint, in your Excel, in OneDrive, in Power BI, for you to be able to have easily work with all your files wherever it is. So you will be learning how to use the M365 Copilot, which is you can create more agents to do different things here, reference different files here. And the last one is the Copilot Studio. So all these three are what you will be hearing from us all through this track. The regular chats, which is similar to ChatGPT, drop your prompt and you get response. The M365 Copilot that will enable you to use Copilot inside all the 365 applications. And the third one, which is the Copilot Studio, that will allow you to create agents, create chatbots for different use cases. So we will be talking about all this in the next few weeks. Yes, Joanne. Okay, you mean what is Power BI? Power BI it's an application for data analytics. So you want to use it to build reports, to build dashboard. So it is Power Business Intelligence. It's one of the Microsoft applications for building report for analysis. So that's that. So this is where we will end the class today. It's just about introduction and then to just show us what's coming, how to use Copilot, how to use Copilot Chat, Copilot 365, Copilot Studio, so that at the end of the course, we now know how to be able to use all these tools effectively. So I'm having, can I change my persona each time I want to generate a prompt? Of course you can. You can also create what we call, you customize your Copilot or you customize your ChatGPT and say, this is how I want you to be responding. But I'm guessing what you're asking is each time you want to prompt, you can change the persona. You can come to Copilot chat here and say, for this time, act as a Gen AI expert. Okay. And then I said, explain MCP. the response will be better than the first one. So next time I can still come back here and say, act as a Nobel laureate winner, you know, write me a love message. You can do things like this. You can still say, look at it, my dearest, as a Nobel laureate. Okay, so you can change the persona every time. You will get the recording. So we can continue with the questions in case we've got questions that you want to ask. And while still be checking the chat, I think somebody asked the question earlier. Okay, I think what's the difference between building your own co-pilots, your own chatbot with co-pilot, and then using the model context protocol? When you're building your own chatbot with Copilot, uh, you're already working within the Microsoft tools, and then you're connecting the Copilot's built-in models and features. You can customize how it behaves, or maybe even connect it to your company's data and shape the responses, but you are still working mostly inside the Copilot ecosystem. It will handle the underlying model decision, the data access, and the user interaction flow for you. But on the other hand, when you use MCP, that's like the buzzword came out, I think early this year or so, you're designing a more structured and flexible system that can control how different models interact with the context. So MCP will allow you define the clear rules, the input, the layer of context that guides how the model generates answer. So invariably, you have a free hand to be able to do a whole lot of things when you're using your MCP on most of the time the open source model. But for Copilot, a lot of the heavy lifting have been done by Microsoft for you. So you are not necessarily going to be bothering yourself about, how to define the rules, how to do your own chunking yourself, all those heavy lifting have been done by the co-pilots. The co-pilot studio is just drag and drop. You're not writing lots of codes. In fact, you don't even need to understand Python to be able to create the co-pilot using the co-pilot studio. Okay, so that's like one of the differences. Okay, so MCP, you have more control over that model that you're dealing with. But for Copilot, it's something that is exciting, that you can be building for different use cases. Like two of those projects are what I'm working on, and one is for people that have been molested, women that have been molested. They want a situation whereby they have a chatbot, something that they can talk to, something that can listen to them, can even suggest hospitals to go with to them, that can even connect them with psychologists or shrinks or whatever we call them to help them out. So it could be for different use cases. So Copilot can be built in your organization for the marketing department, for the customers care center, for the sales department to do many things. And the good thing is that you can also use Copilot to build the Copilot agents you are building. So these are the things that you're going to be learning going forward. It's going to be an exciting track. And at the end of the day, you will be able to create a lot of things and be able to even convert them to skills that's in high demand out there for job opportunities. So I wouldn't know if you still have one or two questions.
Is there an AI that is designed to actually generate for a mathematical stuff, like a mathematical tutor or something like that will generate a calculation aspect?
Okay, the thing is, you've got many organizations today that are building on some of these existing models. So they are fine-tuning it, to do different jobs. They are fine
Yes.
tuning it. You've got Wolfram, you have Math Solver, you have some of these solutions, even ChatGPT. You can also build what we call GPT or build what we call your own co-pilot for your, maybe you want to be using it to teach mathematics or even to teach maths to your own kids at home. So you can refine it and tell it, this is how I want you to work. I want you to be able to do this. So you can still use the regular Copilot, the regular ChatGPT, just that you can also create something called GPT, give it a lot of system prompts, how you want it to work, so that it will not just be working like the regular ChatGPT and just be giving you something. So there are um, lot of platforms, lot of platforms. Socratic is there, Wolfram Alpha is there, Photomat is there, Symbol Lab is there, Sowiso is there, Alexis is there, Kamingo is there from Khan Academy. You've got all these. In fact, you've got Math GPTs too, Math GPT, GeoGebra. So all these are tools specifically that have been trained and retrained, fine-tuned to help teach mathematics or for mathematical analysis and all that. So you can check that out. A whole lot of them, a whole lot of them. Math Solver, that one is from Microsoft. Students can really, really enjoy that. I hope I'm able to respond to your question. Um, okay. So let me hand over back to MJ.
All right, thank you so much, Olalekan. That's been a very informative, loaded session, to be honest. And even me myself, yeah, I'm making notes. Thank you so much. And then it's quite very interesting. And then the fact that we have all of our audience even to this time, I guess that they didn't find the class boring, rather they, even though it's a lot of information, but I guess they found it quite very interesting. And then, so thank you all for waiting. Next week we will be continuing our session, and the session, next week's session, we thank you all for coming. And then, the recording, like we said, we made available. You will get it. You get the recording. So if you want to enjoy the whole of this, please stay tuned till the end. Next week will be very interesting. We have a lot of things in store for you. But what we just don't want to do, we just don't want to take you want to really take you from the foundation, want you to be grounded, that by the time you are actually speaking or even looking for a job or trying to, you some of the questions that will come up for you, you would have gotten it even from this learning engagement. So thank you so much for staying with us. Please watch out.